This is Algebra 1, Lesson 1-8, Interpreting Graphs of Functions. The objectives are interpret intercepts and symmetry of graphs of functions, interpret positive and or negative, increasing and or decreasing behavior, interpret extrema, which could be relative maximum, relative minimum. We're going to cross off that we're going to be interpreting end behavior of graphs of functions. We will not be doing end behavior. Let's start with the vocabulary. Y-intercept, the y-coordinate of a point where a graph crosses the y-axis. X-intercept, the x-coordinate of a point where a graph crosses the x-axis. Line symmetry, a geometric property of figures that can be folded and each half matches the other exactly. Positive, a function is positive on a portion of its domain where a graph lies above the x-axis. Negative, a function is negative on a portion of its domain where a graph lies below the x-axis. Increasing, the graph of a function goes up on a portion of the domain when viewed from left to right. Decreasing, the graph of a function goes down on a portion of the range when viewed from left to right. Extrema is done for you. The points of relatively high function, which would be the maximum, and relatively low function, which is the minimum, and you can cross off end behavior. Example 1. The graph shows the cost of community college Y as the function of the cost of a community college as the function of a number of credit hours taken. So we have cost for our Y values, credit hours for our X values. Identify the function as linear or nonlinear. Does this make a straight line or not? And you can see that this function is a straight line, so we will say this is linear. Then estimate and interpret the intercepts. So, whenever you're doing this on the assignment, you will want to type out the entire word linear and then type out the entire term x-intercept. What does x-intercept mean? Where does it cross the x-axis? And you can see this function does not even cross the x-axis, so it is none. Now we have to do the y-intercept. Y-intercept by definition is where does it cross the y-axis? And if you look at the y-axis, it touches the y-axis at about 50. So that's interpreting the intercepts and identifying whether it's linear or nonlinear. Now let's look at example 2. Example 2 says the graph shows the cost Y to manufacture X units of a product. Describe and interpret any symmetry. So we are looking for symmetry, and by definition, line symmetry was a geometric property of a figure that can be folded and each half measures the other exactly. Whenever I taught symmetry in the younger grades, I often used the example of a heart. Could you draw a line to represent a fold in this heart, and they would match up on both sides? It's kind of a mirror of each other. if you look at our function, yours looks better than the one I've drawn here, but it appears if we draw this fold right here and we were to fold it, they would be mirror images of each other. So describe where the line symmetry is. The line symmetry is, and we're going to read our x-axis here. The line symmetry is where x equals, and it looks like to be about 30. And that's how you find line symmetry. Now go across the page to example 3. The graph shows the population of Y deer after X years that the animals are introduced on an island. Estimate and interpret where the function is positive. In other words, remember, positive is where the function is above the x-axis, and where it's negative, going below the x-axis, and increasing, when is it going up? Decreasing, when is it going down? And we're going to look for any relative extrema. You can cross off in behavior on this graph. So let's start with positive. When is our graph positive? Let's look at our x values. It looks like from 0 to 6, everything is above our x-axis. So you can say 0 to 6 is where it's positive. Negative, where does it fall below our x-axis? And that's none. There's no negative values here. Now we have to find out, when is it increasing? In other words, when is our function rising or going up? Looks like it's going up, and we're reading on our x-axis, remember. It's going up from 1 to about 3. Is this the only place that it is increasing or going up? And it appears so. Now let's look for decreasing. Again, we're going to look at our x values. Decreasing, going down. Well, it looks like it's going down from about 0 as we go across the x-axis from 0 to about 1.5. Is that the only place it's decreasing? I believe it's also decreasing here on this part of the function from about 3 to 6. So 2 places it's decreasing. Now we need to look for relative extrema. This means, is there a point that is very high, and is there a point that's very low? In other words, is it changing suddenly? So if we're going across our function, it looks like it changes suddenly right here whenever it hits 1 on our x-axis. Since it's going down and then up, this is a low, and we call this the relative minimum, and it's when x equals 1. As we go along, all of a sudden it reaches a peak. This is a high on our function. So we call this a relative maximum. And where is it happening? Remember to read across your x-axis. It's happening when x equals 3. A lot of information to interpret this function. If you don't remember what positive, negative, increasing, decreasing, relative minimum, and relative maximum are, go back to your definitions and that will help you. Now let's look at example 4. The graph shows the speed of a car, and it's x miles per hour, after minutes. These are the minutes, which is x. So we have speed and we have minutes. Estimate and interpret where the function is positive, negative, increasing, decreasing. Find the x coordinate of any relative extrema, and we're going to cross off the end behavior. So if you'd like to abbreviate, where's the positive part of this graph? And when you look at this, it appears that everything is positive from about 0 to 7.5. And negative. Where does it fall below the x-axis? It appears to be none. Sometimes our graphs will come below our x-axis, and we have to tell where that's at. I'm going to be consistent here. I'm going to put 0 to 7.5 so you'll know how to do your assignment. Now let's do increasing. Well, you can see that this is increasing in 2 places here. I see an increase here and an increase here. So we have to describe it according to our x value. So it's increasing from about 0 to 1. You can see this portion right here. And it's also increasing on this portion right here. If you go across and read your x-axis, it's from 4 to about 6. Where is it decreasing? Where are we going down for our function? And again, we have 2 places, and let's read it according to our values on our x-axis. Looks like from about 1 to 4, and from about 6 to 7.5. Do we have any extrema? Do we have any highs and lows? Doesn't matter which one you put first. The relative minimum, where does it have? I would call it like a valley. And it looks like our valley is at about 4. So when x equals 4, that's a minimum. A relative maximum, where are the peaks? Looks like we have a peak right here when about x equals 1. And I see 2 peaks. The other one would be about when x equals 6. And we're not going to do end behavior on this. So these are your notes for lesson 1-8. You have an assignment to go with this. Be looking for a study guide the next day, and following that on the next day, a test.